All right, these are your guided notes for 3-6 on analyzing lines of fit. So we talked about what a line of best fit is already. So a line of best fit is just the line, the trend line that most closely approximates the function data. Okay, so when we draw our trend line, you want to kind of have some of the points above it, some of them below it, and it needs to go in the same general direction. So if you need to pause the video, pause it, and then draw a trend line and see how closely yours lines up. So if you need to pause it right now. Then I'm going to draw my trend line. Okay, so that's what my trend line ended up looking like. Okay, so the next definition that we need to know is a residual. So a residual is basically just the distance between the trend line, which is which predicts the values of the function, and your actual point. So if you go directly up or directly down. So your actual y value, that's from your experiment. Your predicted y value, that is your trend line height, like the point that's on your actual trend line. So the residual is the difference between the actual experimental value and your predicted value. That's what a residual is. So the residual is difference between actual and predicted value. Okay? So then we just subtract the actual value minus the predicted value. The smaller our residuals, the better your model is for the line of best fit. So we want as small as possible residuals. If we have a residual of 0, then that means half of our values were exactly above and half of them were below. Okay, so let's do an example. The data below results in a line of best fit with the equation y equals 0.14x plus 12.8. So this is the equation for our trend line. That's our line of best fit. Okay? And it says determine the residual of each point. Well, these are our actual data points. So when x is 10, y is 12. This is the actual. So to find the residual for 10, we would need to do the actual value, which would be 12, minus the predicted value, which would be what we get when we plug 12 in for x. Okay? So let's plug 12 in for x. So 0.14 times 12 plus 12.8. And then you use your calculator, you type it in, and figure out what you get. So 0.14 times 12 plus 12.8. My predicted value would be 14.48. So I would then do 12 minus 14.48 to get the residual, minus 14.48. And that gives me a residual of negative 2.48. Okay? Let's do one more residual. When x is 15, we want to determine the residual. So at 15, the actual value would be 16. And then we need to subtract the predicted value. How do we get the predicted value? We plug in 15 into our prediction equation. So y would equal to 0.14 times 15 plus 12.8. So 0.14 times 15 plus 12.8. That would give me 14.9. So my predicted value would be 14.9 when x is 15. So then my residual would be my actual, which was 16, minus my predicted, which is 14.9, which gives me 1.1. Okay, I want you to go ahead. There's the residuals for the first two. Your job is to finish finding the residuals for the next three terms. Remember, a residual is the actual value minus the predicted value. Okay, if you need to pause while people finish finding the last three residuals, please do. All right. On the back is a U-try. Same thing, but we have a new equation. Y equals negative 0.58x plus 25.2. So that's our trend line. So that's our predicted equation. Your job is to find all five of these residuals. Remember, a residual is the actual minus the predicted. These were our experimental values. So these are our actual values. Because when we did our experiment, we got this table, right? Our trend line is the prediction equation, what we would predict to get in the future. And so the residual is how far apart both of those are. Okay? So pause it, find the residual for all five of these, and then we're going to move on. Okay? Remember, residual, actual minus predicted. Okay. Correlation coefficient. This is the value R. Okay? So our correlation coefficient is a value that is going to be between -1 and 1. And it indicates the direction and the strength of the linear relationship you graphed. The closer your R value is to 1 or -1, the closer the value is to the trend line. And so a bigger correlation, the closer we are to 1, that would be what we would call a strong positive correlation. Because the closer we are to 1, the stronger our correlation is. The closer we are to -1, the stronger our correlation is. But if our correlation is close to 0, then that would be what we would call a weak. So for instance, if R equals -0.92, that's very close to 1. So I would call that a strong negative correlation. The closer it is to 1 or -1, the stronger it is. The closer it is to 0, the weaker it is. So R equals 0.21, that would be a weak positive correlation. Because 0.21 is really close to 0. Okay? All right. So now when we talk about correlation versus causation. Okay? So it says a student found a positive correlation between the number of hours of sleep his classmates got before their test and their scores on the test. Can he conclude that he will do well on the test if he goes to bed early? Okay? Take a second and think about that. Does going to bed early cause you to do well on the test? Okay? So there's definitely a correlation, right? He found that the number of hours of sleep his classmates got before their test and the scores on their test were correlated. But does that mean that going to bed early and getting good sleep is what is causing you to do well on the test? Or is there just a relationship between sleeping and doing well on the test? So I would argue that there is not causation. Sleeping before the test doesn't cause you to do well, but it might help you do better if you did other things. So there is a correlation, right? Causation means it's what's causing you, right? So for instance, studying for your math test might cause you to do better on the test. But if you did no studying and you didn't pay attention in class and you didn't do any of your assignments, sleeping well before the test is not going to cause you to do well on the test, right? The things that cause you to do well on the test are preparing and learning the material, okay? All right, so that's the difference between correlation and causation, okay? All right, read this last example. The number of cars in a number of cities shows a positive correlation to the population of the respective city. Can it be inferred that increasing cars in a city leads to an increase in population? Why or why not? Okay, take a second, think about it, and discuss that. All right, those are our notes for 3-6, analyzing lines of fit.